In this video, we're going to factor a trinomial using the AC grouping method. First, let's remember that the general form for the trinomial could be written ax squared plus bx plus c, where a is the coefficient of the squared term, b is the coefficient of the x to the first term, and c is the constant term. Anytime we're going to factor, our first question is there a GCF, a greatest common factor? So when I look at this particular trinomial and I look at the three terms, I do not see any common factors. So there's no greatest common factor to factor out at the start. I recognize this as a trinomial where a does not equal 1. I look at the coefficient of the squared term and it is not a 1. So this is a case where I might use the AC grouping method. There are other methods we could use to factor this trinomial, including trial and error, but this video is focusing on the AC grouping method. So in that method, my first step is to multiply A times C and find the factor pairs for that product. So in this particular trinomial, when I say A times C, A is the coefficient of the squared term, so A is 2, and C is the constant term, so C is 40. 2 times 40 equals 80. So AC is 80, and now I'm going to find the factor pairs for 80. 1 times 80, 2 times 40, 4 times 20, 5 times 16, 8 times 10. Once I found those factor pairs, I'm going to choose the factor pair that has a sum equal to b. So choose the factor pair where the sum equals b. In this trinomial, b is 21, the coefficient of the x term. So I look at my factor pairs and I find the one where the two numbers have a sum of 21. So I see that 5 plus 16 equals 21, and I knew that 5 times 16 equaled 80, or AC. So I'm going to use those two numbers, 5 and 16, for my next step, which is to split the middle term of the trinomial using the chosen factor pair. So let me scoot my paper up so we can do that next step. So my original trinomial was 2x squared plus 21x plus 40. So I'm going to use the two numbers I chose here, this factor pair 5 and 16, to split the middle term. The first term will stay the same, but instead of 21x, I'm going to now write 5x plus 16x. And then the last term, the 40, remains the same. Now when I do this and split that middle term using 5 and 16, it doesn't matter which order I put those. I could have put the 16x first and the 5x second. We've seen that before with four-term polynomials, that we can interchange the middle two terms and it does not affect the result. So at this point, I've taken a trinomial and I've written it as a four-term polynomial, and I always want to double check and make sure that the middle two terms add up to the original middle term. So 5x plus 16x equals 21x. It's really good to double check that to make sure these are equivalent. My next step now is to take that four-term polynomial and factor by grouping. So remember, in factor by grouping, I look at the first two terms and I say, what do they have in common as the greatest common factor? In this case, it would be x. I factor out an x and I'm left with 2x plus 5. I then do the same with the second two terms, looking for their greatest common factor, which would be 8. And I factor 8 out, and I'm left with, again, 2x plus 5. So at this point, I recognize these two matching factors, and I bring that out to the front. And the other binomial will be what is left, the x plus 8. So here is the answer to my problem. I have factored the trinomial, and I can, at this point, check my answer to make sure that it is correct. So I check answer by multiplying. So I ended up with the binomials 2x plus 5 times x plus 8, and I could multiply that back out or FOIL it back out to make sure I got that original trinomial. So I get doing my steps of FOILing, and then combining my like terms. I see that I do indeed get back to my original trinomial. So my factored answer is correct.